So let us have one example. So you are having one figure like this. So this is a square. Okay. And this square has area 4 meters square. Now we have the squares inside the square. And like this midpoint. So there is another square. Okay. Again we take midpoint. And we take another square. Again we take midpoint. Like this. And we make another square. Again we take midpoint. And prepare another square. And so on. How many such squares you can perform, means find, or you can have?
Infinity.
Very good. So in this way you can have infinitely many squares. Infinitely many squares. Okay. So you are having each outer square area is this. Okay. And remaining squares obtained by joining the midpoints of the sides, okay, of the square to the previous one. And you are having infinitely many such square. Outermost square has the area 4. Then you will have the area of another this square also. Then you will have the area of this square. Then you will have the area of this square. Then you will have the area of this square. Then you will have the area of next square, and so on. Continue. The question is find the sum of areas of all squares. Okay, there are infinitely many squares, and find out the sum of the area of all. Now, if this is the only you know the area of the outermost square. So first of all, you need to find out the area of all the squares, isn't it? Area of first square is 4, second square, third, fourth, and so on. So how to find out that? So this is the, can you say this side is having 2 unit length, 2 meter length?
Yes, sir.
Okay. So this one is of 1 meter.
Yes, sir.
This one is also of 1 meter.
Yes, sir.
So What is this part then?
We apply Pythagoras and find it.
Pythagoras. Yeah. So you apply Pythagoras. And you will get this as the root 2.
Yes, sir.
So length of the side of this square is root 2. So what is the area of second square?
2.
Yes, sir.
Side square. So root 2 square. And so it is 2. Agree or no?
Yes, sir. Yes,
Yes,
sir.
sir.
First is 4. Then is 2. Okay, everyone? Same way you can
Yes, sir.
continue. You can find one another also like this. So that means this length is root 2. So half of the length is root 2 by 2. 1 upon root 2. Same way you can obtain the length of this side. And then area. Same way length of this side and area. But you will see that it will become half of that. This is 4. This is 2. You can easily find area of third square is equal to half of the previous one. And so you'll get 1. Same way area of fourth square. Half of 1. That means 1/2. And continue. Okay. So series of areas of squares like 4, then plus 2, plus 1, plus 1 by 2, plus 1 by 4, and so on. Agree or no?
Yes, sir.
Okay, everyone? Okay.
Yes, sir.
Is this geometric series?
Yes, sir. With difference with r equals to 1 by 2.
What is the first term?
4.
And what is the ratio? Is it 1 by
1 by
2?
2.
Yeah. So this is the series like A into r power n. You can have n equal to 1 to infinity. No, n equal to say 0 to infinity. So equal to n 0, then 4. N 1, then it is 2. N 2, then isn't it? A r power n.
Yes, sir.
And so what is the sum then? Because modulus r is less than 1.
0.
So the series is convergent. So you can find the sum a upon 1 minus r. So 4 upon 1 minus 1 by 2. And so that is nothing but 8. 8 meters square. You understand? So sum of the areas of all infinitely many such square. Outermost no force and બધા infinitely many છે એનો બીજાનો 4 છે ખરેખર. 2 નો 6 થઈ જાય છે, 3 નો 7 થઈ જાય છે જુઓ. અને બાકીના બધાનો 1 થાય છે. Naturally infinitely many terms હોય તો infinitely many terms નો contribution બહુ ઓછું હોવું જોઈએ તો જ એનો સમ મળે, નહીં તો ના મળે. તો પછી જો આ ત્રણ ટર્મ નું contribution 7 છે 8 ની અંદર. ઇવન આ ચાર ટર્મ 5 1 2 3 4 5 5 ટર્મ્સ નું contribution એ ઇવન 7.75 છે. only 5 terms નું contribution. બાકીના બધા infinitely many terms નું contribution ખાલી 0.25. You understand? Okay, understood this example? Yes or no?
Yes, sir.
Okay. Okay. One more example we can have in this connection, and that is like this. Okay. Question is, you drop a ball, say from a meters above a flat surface. Above a flat surface. Each time the ball hits the surface, after falling a distance h, it rebounds a distance RH, and where r is less than 1, it is positive also. So when r lies in 0 to 1. Question is, find the total distance the ball travels up and down. Up and down. Okay, that is the question. Question is like this. Suppose this is a flat surface. Now suppose from here we drop a ball, and suppose it's here, okay, and this distance is suppose a meter. You drop, no, sorry, okay, a meter above a flat surface. So suppose this is, say, suppose I'm just giving one example, okay. So suppose this is, say, like 5 meter or say 10 meter, like this. Now it rebounds, okay, and after falling a distance h above a flat surface, each time the ball hits the surface after falling a distance h, it rebounds a distance rh, where r is 0 to in between 0 to 1. So here our 10, and suppose r is equal to, suppose r equal to 1 by 2 and a equal to, suppose, say 10. So first time it comes 10 unit. You understand this part?
Yes, sir.
Okay. Now what? So first time it so total distance equal to, first time it is 10. Now what is next? So this is 10 and ball is here, but it rebounds RH or RA. So now it rebounds to 5. You understand? 10 into 1 by 2. So it rebounds up to here. So here it rebounds. Understand?
Yes.
Okay. Yeah. So suppose in our case it is say total sum is first is say A is 10 plus AR. Understood? Now what is this distance? AR. H છે R છે A છે sorry એટલે AR. હવે પાછું અહીંયાથી એટલે આ ડિસ્ટન્સ AR થયો. પાછું અહીંયાથી અહીંયા આવશે. એટલે પાછું આ ડિસ્ટન્સ AR થશે yes or no?
Yes, sir. So 2AR.
Yeah, very good. So that is 2AR. હવે rebound થશે. It will rebound like this. Somewhere here. So each time it rebounds like R multiply કરશો. એટલે આ થશે AR square. પાછો અહીંયા આવશે તો આ ડિસ્ટન્સ AR square જ આવશે. So plus 2 times AR square. You understand?
Yes, sir.
Yes, sir.
Then after that it will be say suppose up to here. So it is AR cube. Here it is AR cube and so on. Like this. This is the geometric series that you are having. This is the geometric series. You understand? And now if you want to find out its exact sum, you can find the exact sum also. Okay, you can find out the exact sum also. Like this. So if I do like this, plus A, plus what? Plus you can take 2A outside. Even R also outside. What it remains? 1 plus R square and so on. Agree or no? And
Yes,
this is
sir.
geometric series.
Yes, sir.
Modulus R is less than 1. So convergent, yes or no? If R is greater than 1, then you can't find. અને જો R greater than 1 હોય તો rebound થાય આ 10 થી બી વધી જાય ઘટે નહીં વધે if R is greater than 1 હોય તો. And so now here you are having A plus 2AR, A upon 1 minus R. So 1 upon 1 minus R. A is 1 and R is R. So you are having like this. Even if you want, this is A minus AR plus 2AR. So this is A plus AR upon 1 minus R. So A into 1 plus R upon 1 minus R. This is the total sum. And if A to be 10, R to be 1 by 2, sum equal to 10, 1 plus 1 by 2, 1 minus 1 by 2. Okay. So that is nothing but total 30 distance cover. If your A is like this. So suppose 10 meter, then this is 30 meter total distance. એક વાર બોલ તમે નાખો પછી પાછો આવે પછી નાખો પછી પાછો આવે નાખો પાછો આવે અને માની લો કે એ ઇન્ફાઇનાઇટલી એની ચાલે જ છે અટકી જાય છે તો આપણે સરફેસના આપણે ગ્રેવિટેશનલ ફોર્સ થી અટકી જાય છે but otherwise if we assume there is no, then it will be continue infinitely many. So total distance covered by that ball is like this. You understand everyone?
Yes, sir.
yes, sir.
So you can write down this example. લખ્યો હોય તો ના લખ્યો હોય તો વાંચો. Written?
No, sir. 1 minute. Yes, sir.
Okay. Fine. You may have in this way also another kind of example like this, that express the repeating decimal, say 5.23, 23, 23, and so on, as the ratio of two integers. Why you can express this? Is this rational or irrational number?
Irrational.
Irrational. Okay. Do the Google. It was in your 9th standard or 8th standard.
Rational, sir.
It's a rational number.
Yes, sir. Rational.
Non-terminating. Yes.
Yes, non-terminating, repeating. Okay, fine. So rational. And if you have any rational number, you can express in the form A by B, isn't it? So can you do like this? 5.23, 23, 23, and so on is 5 plus 23 by 100 plus 23 by 100 square, isn't it?
Yes, sir.
Can you write in this way?
Yes, sir.
Yes. Now let us take 23 by 100 outside. What remains is 1 plus 1 by 100, 1 by 100 square, and so on, infinitely many terms. And this is geometric series. What is R equal to?
1 by 100.
And so it is less than 1. So it is convergent. And you can find out the sum. A upon 1 minus R. A is 1. 1 minus R. R is 1 by 100. Okay. This is what? 100 by 99. So this is 5 plus 23 by 99. 99. 9 5s are 45. 5 and 3. 8. 9 5s are 45. 45 and then, okay. So 518. Yes or no? So this is the way you can have can write in this way. Okay, any number, any rational number you can express in this way. You understand?
Yes, sir.
Yes, sir.
Yes, sir.
So you can do it at home. Like 0.7777. Okay. Okay. So next part is like this. There is one theorem. It says like this. If the series, infinite series an, is convergent, then that's what we have seen. Limit n tends to infinity, an must be 0. Limit of nth term must be 0. But when the series is convergent. Okay. Converse is not true. We shall see one example where limit of nth term 0, but then also the series is not convergent. So only on this side, convergent implies limit n tends to infinity an 0, but this side is not true. You understand?
Yes, sir.
That's what we have seen. That's what we have seen. As I told you last time, that the total sum here, the 8, only says it. Only these few terms are having almost near to 8. That means the nth term must going to 0. Only then the series is convergent. Okay. Now, what does it mean? Where is the use here? Like this. If limit n tends to infinity, an is not 0, then what can you say about this series? See, our theory says, if the series convergent, nth term limit 0. If the nth term is not 0, then what you can say?
Divergent.
તમે 11th માં 11th માં કરેલું છે. P implies Q. What is the negation of that? Not Q implies not P. Yes or no?
Not. Yes, sir.
So
Yes, sir.
if limit n tends to infinity n not 0, then series n equal to 1 to infinity n is not convergent. And not convergent means divergent. Not convergent means divergent. Okay. Like you are having like this. Series n equal to 1 to infinity 1 minus 1 upon n power n. Now you know this is series n equal to 1 to infinity an. Now if you try to find limit n tends to infinity an, then limit n tends to infinity 1 minus 1 upon n power n. This is direct limit. Do you know from 11th 12th standard? आणि डायरेक्ट आंसर से लिमिट नो एक स्टैंडर्ड फॉर्मूला से लिमिट. Limit n tends to infinity 1 plus 1 upon n power n equal to e. This is standard result of limit. तो આ શું થાય? Can I write in this way?
Yes.
Yes, sir.
So what is the limit then? આ લિમિટ e થઈ ગઈ power minus 1 1 upon e. So this limit is not 0. અને જે nth term ની લિમિટ છે 0 નથી. So what does it mean now? Is divergent. Yes or no? Hello?
Yes, sir.
Okay. So now even you can have like this also. Okay, no problem. Yeah. So this kind of test is called the nth term test for divergence. Nth term test for divergence. Okay. Okay. Then, okay, in geometric also there is one example I like to have. Limit in n equal to 0 to infinity cos n pi upon phi power n. Cos n pi upon phi power n. Can you? Hello.
સર cos n pi ની જગ્યા -1 raised to n લખી શકીએ ને આપણે?
Very good. So this is -1 power n, 5 power n. So basically now you are having geometric series. Okay, where a first term is 1 and r is -1 by 5. Modulus r is 1 by 5 less than 1. So convergent. And you can find the sum also. A upon 1 minus r. So 1 upon 1 minus -1 by 5. So 1 over 1 plus 1 by 5. 5 by 6. Understood?
Yes.
Yeah. Okay, fine. So now these are the examples where you are having for the geometric series, then telescoping series, then the nth term divergent test. That means there you are having that limit is not nth term limit is not 0. So you cannot have the convergence. Okay. Okay. Like this is also the example in this category. Series n equal to say 1 to infinity log of n upon 2n plus 1. Here we can use the nth term divergent test. Practice हो એટલે થોડી ખબર પડી જાય આપણને. You can have limit n tends to infinity an. Limit n tends to infinity log of n upon 2n plus 1. Can anyone say what is the limit here?
Sir, one tend करूँ तो of infinity.
Say you can have like this log of limit n tends to infinity n upon 2n plus 1. Yes or no? This n cancel. 1 by this is 2 here. Sorry. Not 2n outside, but only n outside. If I take n outside, inside 2 plus 1, n cancel. Log of 1 by 2. And that is not equal to 0. Okay. And therefore by nth term divergent test, this series you understand everyone? Hello?
Yes, sir.
Yeah. Okay. So then next you are having is nothing but the integral test. There is one concept that is called the integral test. Now, what is that? Let us see. So, you are having one series. Okay, you are having one series. Now, so let an is suppose say fn. Okay, this is positive term, and this function is continuous, then positive, and then decreasing. This function is decreasing. It may happen that this function for some n it is not, but for some, like you are having term 1, term 2, term 3, term 4, term 5, and so on infinitely many terms. Suppose it may happen this function does not satisfy say up to n equal to say suppose 100. No problem, 100 terms you can take it out, and this satisfied from 101, suppose 101 term. Okay, in general we are saying like this: if suppose up to n terms it's not satisfied, and after that it's satisfied, okay, no problem. Mostly it will satisfy from first on, always first term always. Okay, but if suppose finitely many term does not satisfy, no problem for infinite series. Why? Because suppose તમારી પાસે infinitely many terms અને first 100 term નથી satisfy કરતા, behave નથી કરતા, તો તમે એટલીસ્ટ આને જો કન્વર્જન્ટ હોય તો 101 ટર્મ થી ચાલીને 100 ઇન્ફિનિટી મેની ટર્મ્સ નો સમ શોધી કાઢો, અને પછી પેલા 100 ટર્મ્સ નો સમ અંદર એડ કરી દો, એટલે 100 તો વેરી ફાઇનાઇટલી મેની ટર્મ્સ. Understood? So there is no problem. Okay, so this is a function satisfies this condition. ये जो 1 થી satisfy થાય તો આપણે 1 થી જ લેવાનું integration. Integration we need to take from 1 to infinity. Suppose 101 થી satisfy થાય તો અહીંયા 101 થી integration લેવાનું. In general n થી satisfy થતું હોય તો n થી લેવાનું. Okay, then you take fx dx and take the integration. હવે જો આ integration finite હોય, integration finite હોય, so you can call integration is convergent, and then you can call this series is also convergent. But if the integration is does not exist or infinite, so this is divergent. Improper integral of first kind. So then you can say that series is also divergent. This is the concept of integral test. પણ અહીંયા હવે આ જે સમ મળ્યો એટલે આ ફાઇનાઇટ મળી વેલ્યુ, એ સમ નથી, એ ધ્યાન રાખવાનું. Suppose this integration is having the value something like say p finite, તો તમે એવું નહીં કહી શકો કે આ જે સિરીઝ છે એનો સમ p થાય છે, એવું નહીં કહી શકો. ઓકે, ખાલી આટલું જ કહી શકશો કન્વર્જન્ટ. હવે આટલું જ કહેવાશે કે સમ ઇઝ પોસિબલ. વોટ ઇઝ ધ સમ વી ડોન્ટ. Okay, so this is the about integral test. Write down. આપણે એક એક્ઝામ્પલ લઈએ એટલે આઈડિયા આવશે. ઘણી વખત એક ના એક એક્ઝામ્પલ ઘણા બધા પ્રકારે સોલ્વ. Let us see. So this is integral test. Done? લખાઈ કાઢ્યું?
Yes, sir.
Yes, sir.
Okay. Let us take one example. Check for convergence. Series n equal to 1 to infinity. Say 8 tan inverse n upon 1 plus n square. Okay. So this is series an, where an is 8 tan inverse n upon 1 plus n square. So let fx, function fx અહીંયાથી જ બનાવવાનું, 8 tan inverse x upon 1 plus x square. Now this is continuous function, no problem, continuous. બીજું કે decreasing પણ છે અને પોઝિટિવ પણ છે. decreasing છે એવું કેવી રીતે ખ્યાલ આવશે? તો કોઈ પણ તમે વેલ્યુ લેશો x ની વેલ્યુ 1 2 3 ગમે તે રીતે, તો અથવા તમારે કેલ્ક્યુલેટર પર તમે બે ત્રણ વેલ્યુ લેશો એટલે આઈડિયા આવશે. x equal to 1 લઈને વેલ્યુ લેવાનું, ગ્રેડિયન્ટ મોડ રાખવાનો, 2 લાઈન વેલ્યુ લેશો, 3 લાઈન વેલ્યુ લેશો એટલે આઈડિયા આવશે કે ડિક્રીઝ થાય છે. Okay. So now we take the, and this is true for n equal to 1 to infinity. Okay. So we take from n equal to 1 to infinity, not needed, and 1 to infinity fx dx. So 1 to infinity tan inverse x upon 1 plus x square. What is the integration of that?
Tan inverse n whole square upon 2.
Very good. Very good. Or you can say tan inverse x is equal to t. So then this is 1 upon 1 plus x square dx equal to dt. So this is t dt. But then if 1 is there, limits. For x to be equal to 1, what is t? Tan inverse 1. What is tan inverse 1? 5 by 4?
5 by
4.
45.
5 by 4. And when x tends to infinity, tan inverse
5 by
infinity,
5 by 2.
5 by 2. And so this is 8 t square by 2, pi by 4 to pi by. Yes or no?
Yes, sir.
હેલો, હવે આનું સિમ્પ્લિફાય કરવાની જરૂર નથી, લાગે છે જરૂર સિમ્પ્લિફાય કરવાની? Why?
No, sir.
Not needed to simplify. You only want a value finite છે કે finite નથી એટલું જ જોઈએ. Okay, you want only that. So this is finite. This is 100% finite. And therefore, by integral test, series n equal to 1 to infinity 8 tan inverse n upon 1 plus n square is convergent. Okay, it is convergent. You understand? Only you can say convergent. You cannot find sum. A value avi sum nathi. Okay, everyone.
Yes, sir.
Yes.